Chan, and we're back on stream for probably a short one, but I wanted to do a little bit of Purescript. So let's get to it. So last time we were playing with the Purescript Commodity QI approach, which Phil Freeman did in Purescript React Explorer. And yeah, trying to wire things up so that we can get to the point where at least I'm doing some of the side effects generation to write to the chronofold data structure, and especially send things to the network, and then same receiving from the network, which is where we get stuck when we're trying to do the same thing with the static DOM approach. So let's see how far we can get. I get the feeling that once we get there, probably it's not going to be as elegant as I would like. And so we'll probably then try and hook up the Purescript run streaming more perfunctorial FRP approach underneath, like driver-like Cycle.js. I don't know. That's just some thoughts here. Let's see whether we can get to something like that. And I'm going to also put in my the chat on my phone. Okay, there we go. All right. So at this point, what we have is so we have monadic values that are built from the interpreter directly using the co-constructor. And then we have an eval, which is really counter interpreter is actually the type of interpreters, whereas eval is actually an interpreter. It's like a stateful interpreter in this case. So you know what? Just to actually make that more clear, I'm going to call this state state interpreter or something like that. And I'm going to pass that here. And then we'll rebuild and see whether things work for us. Okay, looks like probably it did rebuild. How can we know that for sure? Oh, what's going on? Ah, right. Yeah, of course. So that's not going to work actually, because I do need to pass state into the interpreter here. Huh. Okay, so for now, let's keep it in the where clause. Something to think about. I think I'm going to need to, okay, it's rebundling. I need to think about how that works with an actual state monad. So maybe I write this into the log. And let's do a little bit of housekeeping here. And I started on 9:30. Okay. So we are at 26. Okay. And we are also working on the prototype. And okay. So that's done, and we're still on the way to porting things, but one thing I wanted to try was counter interpreter as a state monad. Okay, so that's, I'm not going to touch on that today. Okay, so the important bit is to first of all wire Purescript chronofold. So let's see how we did this over here. So there's the sending receiving, that's one thing, but there's just the stateful log appending as well. So how did that work? I think I'm going to grab some of the well, yes, I'm going to need this for sure. That's empty. don't think I need any of that now. Right, so I'm going to need this, and I'm going to need to import a number of chronofold things. That would be in data chronofold. And then I need to bring in some of the tooling. I think backspace, enter, key up. Oh, hey, Manu Glove, how's it going? In JavaScript we trust. Sure, we do. This code is actually Purescript. Um, Purescript, let me bring up my little speech on Purescript. Purescript is a strongly typed, purely functional programming language that compiles to JavaScript. That should probably be in there, right? That compiles to JavaScript. So the good thing is that it runs everywhere that JavaScripts run. And so, that's nice because we can use it in the browser. And what's a strongly typed purely functional programming language? Well, it's a style of programming that's not quite unlike TypeScript, for instance, right, which also has types. But it's using a specific style, something that uses what's called pure functions and immutable data structures, which are really a way to avoid having a whole bunch of bugs that you normally have in your code. And one of the things that's nice about strong types is that the compiler is definitely helping you out while you write it. It sort of tells you whether things are consistent and coherent. And also types are not just something to check. It is also something that express what you want your program to do in ways that are um, a little bit more rigorous than in other programming languages. And so that means that actually patterns in code are really reusable, and you can um, refactor things. Um, you can refactor your code without a sweat. That's how I would say it. It's really this class of programming languages, functional programming languages, because you use pure functions, it really means that you can switch things around. And if your types check, then usually you know that you haven't modified really your functionality. So, yeah, that's the programming language that we're using here. And yeah, right now I'm using it in the browser to do this thing. So if I walk you, before I add some more stuff to the code, if I walk you shortly into what I've been doing, um, this is the code for now. What does this do? So here I have a div that contains an h1, which says editor, and it also shows the count, which right now is 0. And then in another div, it uses the class name editor, which creates this white border in my CSS. It has a width of 400, a height of 400. Well, that's not true. It clearly doesn't have a height of 400. I don't know what's happening there, but and then on key up, it's going to increment things. And yeah, and the text in it is blah. So on key up, if I type my keys or any key, it's actually incrementing. So that's really just an example right now. What I'm trying to do is a collaborative text editor, which is basically going to use this data structure called a chronofold, which I was in the process of importing here and that I've worked on previous streams, in order to basically have several browsers connected over the internet and do the same thing that Google Docs does. So, and that's a fairly new data structure that does this thing. So I've been kind of kicking the tires and then also using this as a sort of training exercise to get better at some of these Purescript based UI frameworks. And so I'm using one that's fairly obscure. Yeah, and I'm liking it. So that's what I've been up to. There's a MicroPython. Have I tried it? No, I haven't tried MicroPython. There might be one, but I don't think it connects to this because Python is not a functional programming language. So I think it's possible to write Python in a kind of functional programming style, but like Python, like pure vanilla JavaScript, are more imperative, and then Java, C++ are more object oriented, and there's a whole class of other programming languages called functional programming languages. Uh, um, Haskell being one of the other ones that I stream about. And if you look at what does Wikipedia say about this? Programming paradigm, programs are constructed by applying and composing functions. And it's a declarative programming paradigms in which functions are trees of expressions that map. Okay, that's in typical Wikipedia technical article. It's not necessarily the most accessible thing ever, but yeah. And so you could say there's functional programming languages, declarative ones, imperative ones, and Python and all those are more imperative. C, C++, Java, JavaScript, Basic, Python, Ruby, and most other programming languages are imperative. As a rule, it has explicit loops, for, while, repeat, that change variables with explicit assignment operation at each loop that is imperative. SQL, XSLT, and so Purescript, Haskell are well-known examples of declarative programming. And markup language is also declarative. Yeah. So yeah. Oh yeah, SQL being one of the main examples there. And then functional programming is all this stuff. Let me send you this if you want to read about it. It's not bad. Boom. Hard for you to follow that. Your Arduino language C is not higher than that. Yeah, yeah, yeah. You know, I only started the functional programming languages about maybe now 6 years ago, I think. And it took me a while to really get into it. And, you know, now I'm streaming about it, but I feel like I'm still learning and I'm sort of intermediate on it. So it is kind of a very different style, especially when you add types and a lot of people try and then they look at the code, they don't understand it, they're like, oh, I'm not going to do it. You know, that's what happened to me. I knew a lot of programming languages and I thought, oh, it's easy to learn a new programming language, right? They're all kind of the same. And then I looked at Haskell and Purescript and I was like, I don't understand any of this. And at first I like put it back into its drawer thinking, okay, that's not for me. And then later I picked it up again being like, oh, how come there's a programming language I don't understand? So I was a little bit, my pride, I suppose, was a little bit hurt. And that works well to get me to do something. So in the end, I stick to it and learned a lot. And now it's really, I think, my favorite style. And I actually, this year, I started working. My professional life's been impacted by this. I also work writing Haskell these days. Hard to find an audience to see Java development without colored lights in the background. Oh, is that so? Uh, uh, do I have colored lights in my background? I suppose it's not super colored lights, but yeah. It's a bit psychedelic, those are what's happening with my OBS, though. I don't know if that's what you mean. All right, let's get back to doing some programming. Okay, so chronofold. I'm importing this. Okay, unspecified import, we don't mind. And I was looking at a previous experiment and trying to add things from that previous experiment to see how I can reuse them in the new user interface framework I'm using now. So this, for instance, is yeah, appending with an existing log and an operation. It's giving me a new log. And that's another version of that that takes an array of operations instead of an operation. Okay, and so I think I need to import code points from here, I believe. So from data string, I'm going to need to check whether I have those things imported. Maybe I do, but I don't have unsafe throw expression. Picture is clear and the sound is nice. Glad to hear. I usually have better sounds, but now I'm remote working. I'm usually based in Berlin. Right now I'm traveling to Madrid, so I don't have uh, my preferred microphone here. But thank you for telling me that it's not too bad. I like it when the sound is nice as well. Okay, unsafe throw expression comes from effect expression, so we're going to also import that. And now what do we have? No type declaration. Okay. Yeah, so those are just warnings now, so that's good. So the type checker is really helping me figure out whether my code is correct or not. So that's really nice. And what do we have here? Right. So here we have key up and we write. Right. And then the action is I had an action that was writing. So I suppose I'm going to need to put together a data type that's not counter, and that will be basically editor, or um, let's say chronofold model, and that will have probably the log, which will be a log, and then I have a chronofold interpreter and of a type A, and we'll do the same thing here, and we'll have a couple of primitives here, which would be, let's see. Oh, you propose a test. Leave a still image of any woman in a place of the camera for a moment, like a scientific study, too much that I would bet that many people would pass. Um, Manu, I'm not sure what you're getting at, but you're going to have to explain to me what your experiment is. I'm happy to participate in an experiment, but I'd like to understand what you're experimenting with. Because right now it sounds like you're experimenting with me, and I'd like to have informed consent, as it's called in the scientific community. Okay, so let's see. What would be the things that I can do here? I can, well, probably I can append, which in this case maybe is simply this type of log, maybe up log. Is that a correct interpreter? Well, I suppose, what do I return? I suppose here the idea is I can return either unit or some state, right? But here I'm mostly using unit. And here, however, I'm using the model. So yeah, I'm using the model when I'm actually writing the actual interpreter. So I think, yeah, I think it would be maybe for now I'll just call it log. So it's just a basic type synonym right there. And then here is A. Let's try like this. And what's the deal here? Cycles are disallowed. A cycle appeared. Oh, yeah, it needs to be a new type. Okay, all good. I suppose it could probably just be a type, in fact. I'm not sure why I use a new type. So let's try with just a type, like so. And it's not very serious on your part, you understand. Okay, all right. Yeah, I'm sure you can find plenty of still images of women on the internet if you need to see some. I understand the need, but I think I'll keep this to programming if you don't mind. All right. Okay, so now from there, I should be able to also, oh, well, I want to derive, that's why it needed to be a new type, it's because I want to derive some instances. Okay, I get it. And I can't derive instances for type synonyms. Oh, that's new. And that will be functor chronofold interpreter, and it would be functor. I think I need to derive this, but I'm not even sure at this point. And then I probably want the chronofold space as well, co-free of chronofold interpreter. And then I want to yeah, use the append, make this of type probably counter, well, yeah, chronofold model. to chronofold interpreter of so do I want to yeah, I think I need to return a chronofold interpreter here, a chronofold model. It's all a bit verbose. It feels a bit like Java. I'm not sure I like this. But here would be the log, and then actually append will be append, and that's it. I don't think I need to do, oh yeah, no, of course, I need to take a maybe up, right? Maybe up. And so in that case, maybe I do call this append prime. And maybe I call this append second. I mean, this appends an array instead of a maybe. But then append log and up, and that some space there. And the append forms a label I can see. Go to append, append. Right, yes. So actually, this syntax right there, it's the way that I'm describing what's called a type. So you know when I said Purescript is a strongly typed purely functional programming language. So my types are actually those things that I prefix with this double column notation. So when I say append a double column there, what follows is the type. So for instance, if I say something like I can say 1 is of type int, and then I can say that 1 is equal to 1. And then I can say like add is of type int to int to int. What does that mean? It means that adding is taking one int, another int, and then returning an int. So I have an x and a y, and then if I return x plus y, then you should be able to see somewhere if I, for instance, say like let's append this here. If I show 1, hopefully what we'll see here. Let's see, did it compile? I'm not sure it compiled. Yeah, okay. Counter model. Yeah, I seem to have commented out too many things. And yeah, okay, that's rebuilt. And okay, redundant. Okay, I think I need to reload this. It's rebuilding and okay. Maybe I need to restart my IDE. Okay. Rebuilding. Still not. Okay. Okay, let's try to build it here. Chronofold. Yeah, I'm not sure why it's rebuilding the whole world there every time. It's a little bit strange. Okay, padding main. Build succeeded. not sure what's happening here. Okay, you know what? I'm going to close this and not save this, but I'm going to then open a dedicated IDE for this. I haven't restarted this computer in a while. I'm thinking it's having a hard time. And save. And then that seems to rebuild. And then still not. What? Dev tools. Network. Okay. Do I have? Okay. Let's stop this. And okay. Right. It resists something it doesn't like. Yes, it does. It does. Maybe I will figure it out, or maybe not. Okay, let me try something. I will. Let's double check index.js here. Output main, right? So let's remove the output and recompile. Is that Jar Jar Bing? I think it's Jar Jar Bing. It's your fault you're deconcentrating. No, no, it's not your fault. Not at all. It's actually helpful because it means that otherwise, even the rest of the code that I'm writing wouldn't be working properly. So it needs to be sorted. Okay, it's building. All right, and maybe it is the demo effect, but still, demo effect needs to be tamed. Indeed, still not working. Okay. So let me double check what I'm doing here. App container, for prototype. I'm supposed to have changed something here. And okay, in theory, I'm in the same folder, right? SRC main.pers. And yeah, I have the question mark here. So let's look at the code output. I suppose it could be the dist. That cache could be not up to date. Okay, how's that? Still not, okay. Fold, prototype with a question mark. What? Okay, so maybe it's the browser that's browser cache somehow playing with me. Okay, let's launch Safari. Why not? There we go. Okay, so Chrome is locked into some kind of cache. Oh, well, that's really strange. Network, disable cache. Okay. Okay, it was cache. So we're good now, hopefully. So let's go back to what I was explaining. Scarab 2 is doing some really cool in Java, French language. All right, you know I'm French too, by the way. Toi aussi, j'imagine, alors, Manu. Mais par contre, je stream en anglais. But cool to know. Okay, so what was I showing? Okay, look at this. Now it's working. So what I was explaining is here, this second number. Okay, let's just have Manu's number right there. Okay, Okay, so Manu, editor 0, it's not a football match, but uh, so I'm showing the variable called 1. And the variable called 1 is just 1, right? Okay, so nothing very fancy here. But here I created a type called add, right? And add is taking an int and then another int and then returning an int. So what does that mean? Well, I could do maybe add 1. What would that do? And what that does is an error. It tells me, hold on, like actually you're giving me something from int to int. And that's because actually I forgot to pass another int to add, because add takes two ints. So it has two arguments and then it returns an int. Okay, so let's pass it two ones. One, add one, one. And if I save that, boom, menu two. There you go. En español, español un poquito también, pero soy en Madrid, pero no hablo español muy bien. Le ha aprendido un poquito en la escuela, pero no puedo streamar en español. But in English, I can, I suppose, more or less. So yeah, see, I'm using this function called add, and it's telling me that its type is int to int to int, and I'm passing it an int and another int. Actually, I could even pass it this int, and it would do 3. There you go. So all of this is nice because if I say, well, now I'm going to pass it like a, it's going to say, no, hold on, like you're passing me a string, but I want an int. And you know this thing there, right there, like that's because of strong types. So when I say Purescript is a strongly typed functional language, it means that it's telling me, no, I'm sorry, like you said, you're lying to me. You told me that add took an int and an int, and now you're passing me a string. So I'm not going to oblige. I'm going to give you an error. And so what this means is that, as I said here, the compiler helps check my code before it runs. And so that's really nice thing. And you know, you have types in Java, but the types in PureScript are better. But I'm not gonna go into that too much now. But I just wanted to show you what types are quickly. Okay, so I'll go back to what I was doing and try and continue thinking whether I can use append prime here with a log and maybe a maybe op. It's really a maybe op here. It's not an op. And then I need to return a co-chronofold interpreter, right? So yeah, that's I suppose is where I reach for what I did in the previous stream, and then see if I can actually I'm going to display it like that, and maybe also ask to word wrap. And right, so here, I don't know that I can do this nicely. So I think I want to return a append prime log. I want to return a chronofold model, but inside a co-chronofold interpreter. And so here I'm taking an append chronofold. Hey, thanks for the follow, Manu. Really appreciate it. Awesome. And also Cenobite of Sec has followed me a little bit earlier. And Cenobite, thanks a lot. That's really appreciated. And yeah, your test works. You can unfollow me now, Manu. Okay. So yeah, append chronofold, and I pass it where do I pass it? I pass it an A and a maybe up, and I'm supposed to return an A. Yeah, that's totally fine. So I pass it, I pass it the log and the mop, and then I I actually return that very thing, and then it's just that my interpreter is going to need to well, first of all, I suppose the question is whether I start doing algebraic stuff with my interpreters, like sums of interpreters already, or whether for now I just try and do just a regular interpreter. I think I'll try with that first. So let's do chronofold interpreter of chronofold model. And that's going to be something like chronofold interpreter of append chronofold. I mean, in truth, we really want to pass it probably the state. And I think we can't avoid actually passing it also the operation here. So I need to think a bit more about that. I'm not sure how that would work. But here, what I'm passing is basically I'm receiving the log and maybe op, and I'm going to use append prime here to actually realize my interpreter. I think that's what I want. Right. And then here, I want to append, and that's where I would have a log. And so let's take the empty log alpha, or alpha log root, let's take alpha log root and append it maybe up, which would be alpha of p. And so let's call this just alpha of p and return pure unit. Okay, so yeah, here we're now using interpreter instead of state interpreter. And what's the error now? You can't derive this instance. Functor for interpreter A. To counter interpreter. Oh. Ooh, are you telling me you can't because of the negative position A here? Maybe up to B. Huh. Yeah, actually, I don't know if this is the correct shape for an interpreter. And the fact that I have I mean, it's not really, it's actually in positive position here. Is that right? I'm not completely sure. Yeah, you clearly can't derive it. But no, I think this is a functor. So I just need to not derive it. I just need to write it. Where fmap of, what's the type of fmap? A to B, FA to FB, I think. So fmap of a F, that's A to B, and then FA, or an X. And so my F is a function of from A to A. And my X is a kernel fault interpreter. So I'm going to need to probably unwrap that and maybe get the function in there. And then I want to rewrap it and put redo create an append kernel fault here and make it so that it's equal to a function that takes an x and a y, or let's say an a and a maybe up. And then I'm going to want to apply f to a and to return to the result, I think. So f of then chronofold of fa mop. Yeah, it's called map here. And the types don't match. We just, that also doesn't match. Could I match that record with function? Then chronofold is a function from A to blah to A. A to blah to A. So what am I doing wrong here? Then chronofold, that's a to maybe up to A, and I want it to be of B to maybe up to B. And so it does seem like I need to pass it FA if it needs to be B, and then I need to apply F to it. What's the issue here? Okay, I think it's confused about what A is supposed to be here. But okay, I'll take a little break and get myself some water, and I'll be right back. Okay, I'm here. So, what's going on? take an f, then kernel fold. We want it to be a function of a to maybe up. So that's right. Kernel fold interpreter. This can't matter type. So, yeah, no, that makes sense. Actually, yeah, this will actually be a B. That is correct. Ah, if menu equal viewer, menu rien compris. Yes. Well, as you can see, I'm not understanding my code right now either. But yeah, we can write this. We can totally write this. Look. Okay, I'm going to need to comment this out. Okay. Menu compris. Would take what? It would take. Yeah, okay. We'll say compris. Compris takes a viewer and um, returns a boolean. Okay. And what's a viewer? A viewer, let's say, is just for now it's a string. Okay. But actually, we could say it's either. We'll say that it's data type that's either Manu or June. Okay. And then we can say compris and say something like that. And then it would say, oh, here, I can't, well, it can't pass this. What? Okay, well, we could say menu and as you can see, both of us have not complete. so, so now if I say in here, yeah, in here, if I say okay, compris, and then I show compris Manu, compris false. And but the good thing is that compris June is also false. But okay, let's pretend that I actually understand. Okay, it's true. But that's not really what you had. You had a string, right? So let's say now we want compris with an S, and that will take a Boolean and it would return a string. And so what would that be? We say, well, compris false, that will be pas compris. And compris true, that would be, okay, j'ai compris. But in reality, we'll say maybe we're not sure whether we have compris or not. And so now if I say, well, compris of compris June, okay, j'ai compris. So apparently, currently June maybe has compris. We don't know. And compris Manu? Ah non, pas compris. So yeah. Still confused? It's an interesting style, right? But check this out. If I don't do June here, what it says is actually you need to also do the case for June. So, or if I say actually there's someone else here, then it's going to say, hey, you need to also care about someone else. So you say, okay, well maybe someone else uh, is false. And now it compiles. And now we can say also compris of someone else. And he will say pas compris. Yeah, compris. Pas compris. So that's how your code works. No, you're not bothering. Uh, not at all. It's fun, right? It's a programming language. We should be able to think in it, if possible. Okay, so let's go back to my chronofold thingy and see what I'm missing here. And right, so I was trying to write this functor instance. So functor is a bit of a weird beast. Can't really explain that in a second. So we say we pass a b, but yeah, we can't change the b. So it is actually in negative position. That the truth is that it's in negative position here, unless. What if I think of it as being written like that? It's still, yeah, I think it's still negative position. Aha. So maybe it isn't a functor. Is it a functor if I just switch the maybe up? Then can I derive it? Oh, no, I still can't. Yeah. Let's call derive functor contravariant position. Okay, negative position here. Maybe it's an instance of functor. Non-covariant type, make string A to string. So for this, we can only build a contravariant functor, right? Yeah, B to A to make string. But that's not what we have. Is that invariant? It's not, but this is state-like, right? There is a functor instance for states, isn't there? Let's look at the state monad functor instance. S to AS. Oh, do I need to A to B, status A to status B. FAS1. So maybe I do need to yeah, that's not exactly state. I think I'm being confused with that. Why do I think this is state? That's really just sort of mutation, or I mean, we can think of it as the append the update monad too. Understand Microsoft Access quite well and can create an interesting database, but going from that to Java is laborious. Yeah. Coffee, new coffee, coffee refill. It's coffee drink. Yeah, you're thinking code. Nice one. And yeah, databases are also very interesting. I agree. Um, but yeah, programming is a kind of a different thing. It's true. And Java is yeah, Java. To be completely honest with you, I don't particularly like. Um, okay, so okay, there's several directions here that I could go to. Um, one is looking at other interpreters in this sort of how's it called? This free co-free interpreter style. Um, and think about something stateful for that. But it could be that actually the interpreter is not stateful, and it is the sorry, the maybe calling this interpreter is actually wrong because the real interpreter is here, and this real interpreter can be stateful, but the whatever that is, which might not be properly called interpreter, um, that might be called like a primitive or something. It wouldn't be wrong to call it action, to be honest, even though the action is usually the monadic one. Maybe coaction. Let's call it coaction. And in this case, I think we're just saying the coaction actually just takes a maybe up and returns an A. And then if we have that, I think we can derive the interpreter. Actually, yeah. So we can just get rid of that and we can derive it. And then the space and the thing. Okay, and then here that would be a coaction. And here, however, we would be passing a chronofold model. That would be the idea, I think. And so we get our log thing back, except it would be here. The log would be passed here. And we'll pass the mop and the log. And it wouldn't be a counter interpreter, it'd be a chronofold action here. And here, yeah, append would actually only be passing the maybe up. And that doesn't match the type because what? So we pass a maybe up to append chronofold, and then we want to return that A. So I think we just do unit again, or returning the model. So right, so no, so this will also be returning the unit, and yeah, that seems to work. So that's really just the shape. It's really the fact that it takes something, that it takes this maybe up, but the real interpreter is here. And does this compile? Let's see. That doesn't seem to compile. What's the error? Match log. Right. Okay. In this case, this is prime. And this, yes, this will only take the up and would start with alpha log root. Here. Yeah, so actually, yeah, of course, what I should do, this is step counter. And what I should do is do editor and say that it's component of chronofold space and say editor equal build free of co-free step chronofold of alpha log root. Alpha log root. And then here I'll say that this is the step editor. Which takes a log, which is the chronofold model, and uses the returns the chronofold model as well, and of chronofold interpreter, and chronofold space here, and this would be step counter, and then this would be this thing, and this thing, and that would be step counter, and right, it's chronofold coaction now, and we wouldn't be showing count because we wouldn't have count, and this we would be calling counter, and we wouldn't need that div here. No, we need yeah, I suppose we can do this and maybe this. That would work. And then remove that. Maybe we need a tab index, possibly. Let's see, and then we remove that whole thing. And now we have a step counter with some stuff. I'm actually going to move all of the chronofold stuff below here. And what are we missing now? Another step chronofold. Yeah, that's because this is now step editor. Sure, let's call it step editor. Okay, and now we are we need this interpreter there. And right, so I want to return a chronofold coaction. Interpreter is supposed to take the chronofold model, but that's wrong. Actually, it doesn't. It just takes the log from the closure. But that's still not good. So A equals CH shouldn't have a parenthesis to achieve the current value. A equals CH. I'm not sure where you mean A equals CH. If you have a line number, I can maybe see what you're saying. Okay, so interpreter the chronofold action, chronofold model. Let's just double check here. Counter interpreter, counter model. That works fine. I suppose I do need the co-counter space thingy. Co-chronofold space unit, that seems to be here. What's the deal? Ah, it needs to return unit. Is that the problem? Okay, append prime takes a log and a maybe up and returns a log. Yeah, no, so that's correct. I think I want to return a log, which is the chronofold model. There's something strange going on with syntax here. Can I match record with function? That's a bit strange, isn't it? Chronofold correction, pen chronofold, maybe up to A being a chronofold model. Do I need to do this? Oh. Oh. Oh yeah. Okay. Yeah, I think yeah, this compiles. Okay. Cool. And then maybe editor here. Does that work? Yeah, I think. And this counts, and oh, this blows up. But it does a thing. It blows up. 97. Ah, this thing right there. So A equals, right. So the way that this reads, parentheses to achieve current value. Right. So let me explain what new type means, especially since we compile now, so we're happy and we can digress a bit, right? So remember we had data viewer equals menu June other. And then we could say something like compris equals, compris is of type viewer to Boolean, for instance, right? And we say, right, compris menu a compris, and nobody else has compris. So we can say that everybody else has not compris, for instance. But let's say we say, well, but hold on, we don't really want a Boolean here. We want a message. And so we can say new type message is a message with a string in it. And so now I can say message compris, and here say message pas compris. And I can then do something like in my editor, I can show compris of menu. And that's actually not a very good example, to be honest. Okay, let's do a better example. So let's start with this. And now Manu a compris, but June n'a pas compris. But let's say actually we also want to know about when. So we could say new type uh, when is when and an int where we say that 0 is today and 1 is tomorrow or something. So now we could say, okay, well, we don't want, it's not about maybe today we haven't compris, but maybe tomorrow we will have compris. So tomorrow maybe Manu n'a pas compris, or today Manu n'a pas compris. But maybe tomorrow Manu has compris. So here we see there's a problem because compris should have a when, but here we're passing it an int. So we should say when 0 and when 1. And we need to also have two things here. So now we say, okay, has June compris today? When 0? And no, June has pas compris. And how about June? How about Manu today? Manu today n'a pas compris. But how about Manu tomorrow? Yeah, Manu tomorrow has compris. So a new type is a way to say, okay, I want to have something I called when here. That's a type called when, but it's actually just a wrapper for int. And so each time I call it, I need to prefix it with when. I don't think this is a good example, but it's an example. So there you go. You have it. And you know what? That's going to be it for me today. I've got a little bit further forward here. I've actually started hooking up the chronophore data structure again. I actually also managed to build up this core action type, which I think gives us the right shape and an interpreter, and I think a stateful interpreter too. I haven't really gotten to try and it actually seems to blow up. So with some error, I suppose, yeah. And the error is didn't expect the timestamp to already exist. Okay, so that's good though, because that's the underlying that's the Purescript chronophore library that's telling me something there about the timestamp. So it's kind of working. I mean, it's I think it's just a matter of continuing a bit next time. And next time will be on Tuesday. So more wiring of chronophore. Manu, thanks a lot for joining, following, and getting me a chance to explain Purescript and strongly typed functional programming. And holy moly, this light is a bit crazy, right? But it's just how it is. But yeah, come by on Tuesday if you want to see more of this. And it was nice meeting you. Take care.